So I'm going to pour hot water into here, and what's going to happen is the temperature is going to drop off. Now, the rule for this is that the rate at which the heat flows, right, is proportional to the difference in temperature between the what's in the beaker and what's outside the beaker, right? What's outside the beaker is ice and water, so we think that the outside temperature is 0 degrees Celsius, right? And what's in the beaker is going to start out boiling, but it won't be for long, right? So we've got a beaker. This is going to be hot. This is, of course, nice stirred ice cubes, right? This is cold, right? Now, if the heat flows quickly when there's a big temperature difference between here and here, and more slowly when there's a small temperature difference, what is the curve going to look like of temperature versus time? Big T versus little t. Go down straight at a constant rate. Curve, how's it going to curve? Could curve a lot of ways, right? It could go like, yeah. Could curve like, could be a straight line. Could be. Which one's it going to do? What makes sense? The downward curve. Which one's the downward curve? Really quick and then evens out at the end. Why? At the beginning, why is the heat flowing quicker at the beginning?
Because the hot's really hot in the beginning.
And there's a bigger rate of heat flow. It depends. So this is Newton's law of cooling, right? Newton's law of cooling states that heat flows quickly when there's a big temperature difference, less quickly when so this thing here is our heat flow rate, right? Right? So when there's a big temperature difference, heat flows quickly. When there's a small temperature difference, heat flows more slowly. So let's set up our data acquisition here. Whoops, it's not even there. Okay. So I think what we want to do is we want to set this up for 100 degrees, and we want this to be data collection. Let's do once a second. We used to do this by hand for 400 seconds. Yeah? There we go. Changes that. All right. Are we ready for this?
I'm ready.
Is the world ready for this?
I don't think.
Watch the temperature at the bottom there. I'm going to pour this stuff on there. Okay. Uh-oh, it's tipped over. And now I've got a little problem here. Okay, monitor and adjust. I think we're good. Okay. Okay, here we go. Okay. Is it hotter now?
Yeah.
There we go. That's good. So let's hit collect. And there we go. That's pretty cool. Is that cool? We'll let that go. So it's dropping off quickly at first. We can start to check on it. Does that look good? Yeah, it looks good. It's still stirring. And let's talk about the first law of thermodynamics.